morning, my dear students. My name is Hemant Verma. I am a student professor in Technocrates Institute of Technology, Bhopal. And in this session, we will discuss about the time domain analysis. So, what is the time response? So, the output of the control system for the input varies with respect to the time. So, the time response is divided into the two parts, in the transient response and second is the steady state response. So, with respect to the time, the transient response will be fluctuate with respect to time, and after some time, when transient response will be die, then this process, when we increasing the time, it's called the transient response. After that, the response, the response will start the steady state response. So for the steady state response, the curve will be the constant for the steady state response. Okay. So when we applied the input, the output takes the certain time to reach the steady state output. So output will be in the transient state till it goes to a steady state. So it is the mathematical expression when the limit t times to infinity CTR is equal to 0. So transient response output will be 0 when we increasing the time as in t infinite. For the steady state case, when the transient response will die after the some time, when we increasing the time, so when transient time will be increased, and after the some time when we increase in the time, so at the infinity the transient response will be die. After the dying the response will started steady state response. So for the time response curve, both the signal should be including for the output. First is the transient response and second is the steady state response. So for check the any closed loop system, we generally use different types of input. So generally we use the impulse signal, we use the step input, we use the parabolic input, we use the ramp input. But generally for any closed loop system, we generally use the step input because the output response is accurate and steady state error for the step input should be 0. So we will check all these inputs on the closed loop system and we will get the output. If the output is accurate, then that input signal will be better for that closed loop system. So this is the impulse input signal. So impulse input signal is valid for t is equal to 0. It is not valid for the t does not equal to 0. And again, this is the second unit step input. So ut is equal to 1 when t times 2 t times 2 equal to and increase to 0. When the value will be the t is equal to 0, 1, 2 and so on infinity. Then ut is equal to 1. The amplitude of unit step signal is a constant. And when the 0 is greater than the t, then ut is equal to 0. So it is not valid for the negative value of t time. And for case of the unit ramp signal, the function is rt is equal to t when t is equal to 0 and greater than 0. So curve will be the linear for the ramp input signal. And rt is equal to 0 when 0 is greater than t. So if the value of t is negative, then unit ramp signal will be 0. And fourth case is the unit parabolic signal. For the unit parabolic signal, the function ut is equal to t square by 2. It is valid for t is equal to 0 and t is greater than 0. But it is not valid for the when the 0 is greater than t. So if the value of time is negative, then unit parabolic signal should be 0. So this is the first order closed loop system. So first order closed loop system, first of all, we will find out the output response curve. So in the closed loop system, first of all, we will find out the overall transfer function. So overall transfer function Cs upon Rs is equal to Gs upon 1 plus Gs multiply Hs. So the value of Gs is the forward path. The value of Gs is 1 by H2. So we will put the value of Gs, so 1 upon H2 divided by 1 plus Gs 1 upon Ht and Hs is equal to 1 multiply 1. So result will be 1 upon Ht plus 1. Now we will find out the output. So Cs is equal to 1 upon Ht plus 1 multiply Rs. First of all, we apply the impulse response signal for the first order system. So first order system, we apply the unit impulse signal. So Rt is equal to delta t. So Laplace transform of Rt is equal to Rs is equal to 1. So we will putting this value Rs equal to 1. So result Cs is equal to 1 upon Ht plus 1 multiply 1. So Cs value is 1 upon Ht plus 1. We will take the common of t. So result will be 1 upon t bracket s plus 1 by t. Now we will take the inverse Laplace of this output signal. So inverse Laplace of output signal Ct is equal to 1 by t e to the power minus small t by capital T. Now this is the impulse response curve for e to the power minus t. So in this case, the output response curve, in this case, for the output response curve, the output equation is only the transient term. It is not steady state term. So we cannot find out the output response curve for the impulse signal. So the unit impulse response Ct is an exponential decaying signal for positive value of t, and it is 0 for negative value of t. When we increasing the time for the t times to infinity, the impulse curve will be dying for the t times to infinity. So it is only the transient response curve, which is not a steady state response curve. So we cannot find out the output response curve with the help of unit impulse response. So generally, we are not using the unit impulse response as the input for the closed loop system for finding the output response equation or output response curve. Now, secondly, we will apply the unit step signal. So we know that Rt is equal to 1 is the time domain. So S domain is equal to Rs is equal to 1 by S. Now we know that the output is equal to 1 upon Ht plus 1 multiply Rs. So unit step signal Rs is equal to 1 by S. So putting the value of Rs. So result will be Cs is equal to 1 upon Ht plus 1 multiply 1 upon S. Now this equation, we will solve this equation with the help of the partial fraction. So result will be A upon S plus B upon Ht plus 1. Now we will find out the coefficient. So after finding the coefficient, the value of A is equal to 1 and B is equal to minus T. So we will putting the value of A and B. Then result will be 1 upon S minus T upon Ht plus 1. We will take the common. So result will be 1 upon S minus T upon T S plus 1 by T. T will be cancelled out. So Cs is equal to 1 by S minus S upon 1 plus 1. Now we will take the inverse Laplace transform of this S domain function. So Ct is equal to 1 minus e to the power minus small t by capital T. So this is the output response curve. This is the output response curve for the unit step input signal. So first of all, we will see this output response curve. We will draw the input step signal, and we will draw the output response curve. So in this case, for the unit step input and output equation, we will find out the steady state error. When we will check the steady state error, so this steady state error should be 0. If the steady state error is 0, then we will find out the accurate output. In this equation, we will see that 1 minus e to the power minus small t by capital T. So in this equation, both the term are present. Transient term is present and steady state term are present. Because e to the power minus small t by capital T is the transient term and 1 is the steady state term, because 1 is the constant. So it is represent the steady state term. Now we apply the ramp input signal. So we know that the ramp input signal RT is equal to T multiply U2. Now we will take the Laplace transform of unit ramp signal. So RS is equal to 1 by S square. Now we will putting the value of RS. So CS is equal to 1 upon ST plus 1 multiply RS. So result will be 1 upon S square bracket ST plus 1. Now we will solve this equation with the help of partial fraction. So we will find out the coefficient A, B, and C. And after finding the coefficient, the value of A is equal to 1, B is equal to minus T, and C is equal to T square. Now putting the value of A, B, and C. So result will be CS is equal to 1 upon S square minus T upon S plus T upon S plus 1 by T. Now taking the inverse Laplace transform. So Ct is equal to 1 upon S square. The inverse Laplace of 1 upon S square is T minus inverse Laplace of 1 upon S is equal to 1 plus T. Laplace transform of 1 upon S plus 1 by T e to the power minus 1 by capital T. So in this term, we will see that the output equation is transient term and steady state term, because e to the power minus T by capital T is the transient term and capital T is the steady state term. Okay. But the problem is that when we will find out the steady state error, so steady state error will be larger. In this case, so generally we are not using the unit response, unit ramp input signal. So generally we are using the step input signal, because the steady state error for the step input signal is equal to 0 for t times to infinity. For in case of the unit ramp signal, the steady state error is equal to t, so it is a very large error. So generally we are not using the unit ramp signal for finding the output response curve. Now this is the parabolic response for the first order system. So we know that RT is equal to T square by 2 multiply UT. So it's the time domain function. Now first of all we convert this time domain function into S domain function with the help of the Laplace transform. So RS is equal to 1 by ST. Now putting the value of RS in output equation, so result will be 1 upon ST plus 1 multiply RS. So we will solve this equation with the help of partial fraction. So result will be A upon ST plus B upon S square plus C upon S plus D upon ST plus 1. Now we solving this equation and we will find out the coefficient A, B, C and D. So result will be A is equal to 1, B is equal to minus T, C is equal to T square, D is equal to minus T, T cube. Now putting the value of A, B, C and D in our equation, then result will be 1 upon S cube, 1 upon S cube, 1 upon S cube minus T upon S square plus T square by S minus T square upon S plus 1 by T. Now we will take the inverse Laplace of our equation, then result will be T square by 2 minus T plus T plus T square minus T square minus e to the power small t by capital T. So in this output equation, we will find out the both the term, transient term and steady state term. So in this equation, e to the power minus small t by capital T is the transient term and T square is the steady state term. Now, in this case, the problem is that the steady state error is very large. So generally, we are not using the unit parabolic response, because the unit parabolic response is the second order system response. So generally, we are not using for the first order system. So generally, for checking all types of input, generally we are using the step input signal, because the step input signal gives the steady state error is equal to 0. Okay, thank you. And this session has been completed for the first order system. And next session we will discuss about the second order system. Thank you very much.